6b is the last section of Unit 0, which means now we're at the stage where we should be able to do all the different rules together. And so you're going to see some things here that, in my mind, are slightly trickier than what you've done before. Slightly. But there's no new concept. So let's go ahead and go through. We have 6 examples for you as we do these things. Those are all the 6 problems that we're going to do. We'll start with number 3. Number 3 says write in radical form. This is an exponential form, so we need to write in radical form. The biggest thing I want to point out to you on number 3, this 1/3 power, does it apply to the q and the 5 or just the q? Just the q, which means what's inside the radical? Just the q. So keep in mind this is the root. This is the root. And this is the variable to the first power. I don't really need to write that 1. If you did write the 1, it would be right about here. But I don't use it. And the 5 is just multiplying it. It's 5 times the 3rd root of q. And is that in radical form? Yes, it is. That's your final answer. The reason why I highlighted number 3, the reason why I chose it as an example was because I know some of you or some people will take that 1/3 and put the 5 inside, but it does not apply to it unless there are parentheses. Your job is to know when parentheses are there, it means the whole group, and you're doing those problems. Second example, the 4th root of 2x to the 3rd, and it says write in exponential form. So this whole group is inside the radical, so this whole group is going to be to the 1/4 power. So if I'm thinking about 2x to the 3rd to the 1/4 power, the whole group is to the 1/4 power. What I would do if I were you, because I usually simplify this, is I would have the 2 to the 1/4 power, and I would have x to the 3/4 power. Because you're multiplying. And 3 times 1/4, this is like 3 over 1 times 1 over 4 is 3 over 4. Yes, ma'am?
Why wouldn't it be 3/4? Like, why is that? Because it's just
This one here? Or why is it 3/4?
No, like why wouldn't it be
Over here?
2x to 3/4? Yeah.
Because this 3 only applies to the x. This 3, does it apply to that too? No. Are there parentheses around this where that 3 is for the whole group? No. This 2, it's like 2 to the 1st, x to the 3rd right there. And so when we do that 1/4 power, that 1/4 multiplies the 1, and that 1/4 multiplies the 3. The 3 only applies to the x. The only time that it applies to the whole group is if this 3 were outside. If it were outside here, then it would apply to the whole group. Or if there are parentheses, then it applied to the whole group. That's a good question. Number 10. The majority of the problems will be like number 10, where you're going to have to do something and possibly rationalize and go from there. Number 10 says 64 to the negative 3/2 power. Here's a negative exponent. Negative exponents become positive in the denominator. But you would never just stop in exponential form. What you would do is you would do this in radical form. And then when you're in radical form, you have a choice. The bottom number is the root, the top number is the power. You can either do the power first, or you can do the root first. And I think making it smaller before making it larger is easier all the time. So I'm always going to try to take the easiest road. The easiest road is probably the square root of 64. I think most of you know what that is. What is the square root of 64? And then that little 3 is still there. You still have to take 3 factors of that 8. And I am not sure what 8 times 8 times 8 is. It's 64 times 8. Maybe you do. No? That sounds right. Let me double check. I agree. Number 18. Now this one has a negative 1/3 power outside of parentheses, which means that this applies to the whole group, including that negative. This has a 1/2 for the 81. So I have to pay attention that this is the same thing as the square root of 81. I don't need to put the 1 like that. I have one factor. This, since I have a negative exponent, is the 3rd root of negative 27 in the denominator. That negative moves this downward. Multiply. I'm going to simplify a couple things here. Now the 3rd root of negative 27, can I factor out 3 of these negatives? Think of it like negative 3 times a positive 9. That makes negative 27. And then I could do a negative 3 and another negative 3. If you can factor out a negative from an odd root, I would always recommend doing that. 1, 2, 3 of them. So we have negative 1/3 for that side. The square root of 81, I bet you guys know what that is. It's just 9. Then you have negative 1/3 times 9, which is 9 divided by negative 3. And my final answer is negative 3. Second to last example, 22. Always start with any exponent outside of parentheses. Always start there. So this 1/3 power, the bottom is the root, the top is the power. Anything to the first power is itself, so I'm just going to worry about the 3rd root of this 81 p to the 6th. And so I'm looking for 3 factors to break out of this 81. And I know that 9 times 9 is 81, but that's 2 factors. I need 3. So I'm going to break the 9s apart to see if I have 3 factors of anything. And then I see stuff. I see that I have one group of 3 right here. I can factor out a 3. There's going to be a 3 left inside. P to the 6th means that I have 6 factors of P. I can already see that one P is going to pop out, and so is another one, otherwise known as P squared. So keeping organized, I have a 3P squared on the outside times the 3rd root. What doesn't break out is this 3 right there by itself. And so my final answer is 3p squared times the 3rd root of 3. Last example, number 25. If it can reduce, reduce it. 4, can it go into 27? It doesn't. Always try to make it smaller before you make it bigger. And then you go for it, and then you just you do it. Normally, this would move this into the denominator, but then I don't want you to have a complex fraction. So what I'm going to do is I'm going to put this to the numerator of both of these and the denominator, and I hope you see why in just a second. This is 4. Notice there's parentheses, so this is going to go to the 4, to the negative 2/3 power. And then I'm multiplying here. When I multiply, 6 times negative 2/3 is negative 12/3. Negative 12/3 reduces to negative 4. Let me double check that. Yep, I agree. Over 27 to the negative 2/3 power. When you have negative exponents, they become positive in the opposite place. So that's what I'm going to do next. I'm going to move this one down. 4 to the 2/3 down here. I'm going to move this one up. 27 to the 2/3 up here. And I'm going to move this one down. X to the 4th down here. Now the only thing I'm going to do from here is I'm going to simplify as best as I can. 3rd root of 27 squared x to the 4th. This only applies to the 4th. 3rd root of 4 squared. I think this numerator will be the easiest to deal with. 3rd root of 27, I bet you know what that is. If you know it, say what it is out loud. Ooh, 3. So let me just break it down. 3 times 9, 3 times 3. You need 3 factors. A 3 would pop out. But then you square it. Now it's going to be 9. For those of you who were jumping ahead, that's fine. I did hear a bunch of 9s, but maybe you were jumping ahead. I'm going to give you the benefit of the doubt. Now this one, you have to have 3 of these 4s. Do I have 3 4s? No. But maybe it'd be easier if I had a 2 times 2. I still don't have 3. So then what I'm doing is maybe if I square it and I have another 4 times 4, maybe then I would have enough to break out. 3 of them. There's 3 of them. And now I've used that exponent, so that 2 is going to break out. 2x to the 4th. And then I have this 3rd root of 2 left over. This is as small as it's going to get. The only problem with this answer is there is a radical in the denominator. And in a previous section, we told you never leave radicals in the denominator. You have to rationalize. So if you were to rationalize this, you're going to need to multiply by something. What would I multiply by? I'm probably going to need to multiply by, I need 2 more factors inside a 3rd root over itself. That way, we have 1, 2, 3 factors of 2 that can pop out of this thing, and there'll be no more radical in the denominator. I have a 2 times x to the 4th, otherwise known as 4x to the 4th in the denominator. And in my numerator, 9 times the 3rd root. If it doesn't have enough, you put it back together. You cannot reduce something that's on the inside of radical and something that's on the outside of the radical, so don't try to do that. Something inside does not mess with the exponent, so this would be your final answer. And that's where we'll end your examples for 6B.